function, which is what we call exponential functions. So go ahead and see if the page is already distributed to you. The first thing we will try to do is graph the parent function. So when we say parent function, like it's the most basic exponential function. I'm going to teach you some hacks. I'm going to teach you some shortcuts, and at the same time, I'm going to explain to you as well, like what's happening conceptually, and what's the idea behind it. Okay, so in before exponential function, this is how it looks like. Did I freeze? Okay, now you see it. All right, so let's take a look at the graph of this one. You can fill up the table of values online, or you can do it on your paper. That's up to you. All right, so if we have y is equal to 2 to the x, 2 to the x, that's the most basic exponential function. So, but they don't call it the most basic, they call it the parent exponential function. So that's where all functions come from. In the same way as if you have the parent absolute value function, it's y equal to absolute value of x, right? You remember that from last semester, this was the parent absolute value function. So today we will try to fill out the table for a parent exponential function. So let's log in 2, which is the base is 2, right? So this is your base, and this is your exponent. Now we're going to find the y, right? So 2 to the 0, what is that? In the chat pod, 2 to the 0 is 0. Anything raised to 0 becomes, okay, 1. So that's 1, that's the 0 property of exponent. Good. Okay, now 2 to the first power, 2 to the first power, 2. 2, and then the exponent here, x, is 2. 2 squared, 4. Okay. 2 to the third power, 8. Very good. Please go 2 times 2 is 4 times 2 is 8. 2 to the fourth power, 16. Very good. Very good. All right. So that's how we fill up the table. Yeah. But there's a more powerful concept about it. You know? So in y is equal to 2 to the x, right? The base 2 is the growth rate. So in other words, you didn't have to do all of these. In fact, we can simply say, oh, to get the next number, you just double it, right? So that's the growth factor, that's the growth rate. So this is times 2, and then times 2, times 2, and so on. So even if we don't know how to simplify exponent, we can get what the values for y are, right? Okay, so how do we graph this? So let's graph this one here. If you're graphing online, you could click on draw, right? You click on draw, and then you use your dot or your pen, okay? So I'm going to use my ink pad right here. So when x is 0, let me label this 0. They're too little, so I'm going to spread them out. I'm going to put x is equal to 1 here, so I'm skipping a line, okay? 1, 2, 1, 2. So I'm skipping a line after each. There you go. Okay. And I'm going to erase this extra stuff here so I will have space. All right, and then for my y value, I think maybe I could go with 2, keep a line, 4, 6, 8. I may not have enough space for 16, but that's okay. All right, so now when you graph it, when x is 0, y is 1. When x is 0, y is 1. Okay, and the point 0, 1 is actually called your intercept, okay, which is also called your initial value. Uh-huh. Next, when x is 1, y is 2. When x is 2, y is 4. Looks like straight, but it's actually not. And then when x is 3, you go to 8. Okay, so this is 4. Do I have space for 16? 10, 12, 14. Okay, so this will be 16 right there. Okay, so the shape now is actually a curve. There you go. All right. Okay, maybe you're wondering what can happen on the negative side. What's going to happen on the negative side? Well, let's try. Um, if we use x is equal to -1, what's going to happen to y? So let's see. So if x is equal to -1, you put it 2 to the -1, right? So y is equal to 2 to the -1. Now what happens again when the exponent is negative? What do you turn the whole number into? What will you do if the exponent is negative? Now, if, for example, you're doing homework on your own and you don't know what's going to happen when the exponent is negative, I taught you decimals, right? So that's your best friend if you're doubting your answer. So you enter 2 raised to -1 in decimals and it will display the answer right away. But it's good if you like know why the answer is like that. So if you have 2 to the -1, remember it's going to become a reciprocal, right? So that will become 1 over 2 to the first power, which is pretty much 0.5. Yeah? So that means if I graph here on the left hand side, when x is -1, the graph will be 0.5. So very close to the bottom, very close to the x-axis. So in fact, it's gonna go like this. Okay, it will not cross your y-axis, I mean your x-axis, my bad. And if I could show you a better version of the graph by going to decimals, give me one quick second. If I want you to see what happens on the negative side of, you don't have to do this, I just wanted to show you. So y is equal to 2. Okay, let me see this before that. Right, there you go. Oh, okay. All right. So as you can see, the graph continues to be very close to the x-axis, but it never actually passes through it. Okay, and that's your initial value over there. We call it initial value or y-intercept. Okay, and as you can see on the graph, it becomes smaller and smaller and smaller, but never becomes negative. Okay, all right. So that's the graph of an exponential function. Right. Now, there's another hack that I wanted you to learn. Any exponential function has an invisible number here. You can think of it as, like similar to the coefficient when we were doing mx plus b. Okay, So the growth rate is 2, but the value here, which is 1 times 2 to the x, that's actually your initial value. So the value here, 1, could change. Yep. And whatever the value is, that's going to be your y-intercept. That's going to be your y-intercept. So it's similar to when you graph y equals mx plus b. You get the y-intercept and then you find the slope, right? Because slope tells you by how much it's growing. So same is true for exponential. You figure out where the y-intercept is. In this case, it's the very first number that we got when x is 0. But the shortcut is just get the value here that's multiplied to 2 to the x, right? So in this case, it's 1. And then once you find the initial value, use the growth rate to figure out the other numbers. Okay, so in the chat pod, I'm going to write a function. You're going to tell me what the initial value is and what the growth rate is, okay? What did I do? Okay, all right, here we go. So y is equal to 3 times 2 to the x. What's the initial value in the chat pod? What's the initial value? The initial value is the number that doesn't have an exponent x, okay? The number that is connected to x, that's your either growth rate or maybe I'm going to have another term for it. Excuse me. Okay, so can you tell me what your initial value is for y is equal to 3 raised or 3 times 2 to the x? In the chat box, anybody? If you're doubting yourself, it's actually the value of y when x is 0, just like what we did over here. See, the initial value is the value of y when x is 0. So if you want, okay, let's try. If you substitute 0 for x, 2 to the 0, you're right, Alyssa, that's 1. But now let's multiply 1 to 3. So what's the initial value here? The initial value is 3. So when x is 0, y is 3. Suppose I have y is equal to 5 times 3 to the x. What is your initial value, or what is your y-intercept? What is your y-intercept or initial value? 5. Very good, Giselle. So 0, 5. Okay, now what about the growth rate? So the growth rate is the number that we multiplied over here earlier, remember? Like, oh, 1 times 2 times 2 times 2. So that's the growth rate because the base is 2. Now what's the base right here? What's the growth rate for the first one? So the growth rate is the number that has an exponent because that's what we're raising to the power of. Okay, 1, 2, 3. Very good. So your base here is 2. That's your growth rate. What about in the second one? What's the base or what's the growth rate? 3. Very good. Now sometimes, okay, you also have what we call a decay rate. Okay, so sometimes it's not a growth rate, but a decay rate, meaning it's going down. So for example, if your first value here is 10, okay, if your first value here is 10, to get the next number, you're going to half it. So earlier we were doubling it. So here the decay rate is 1/2. So if the first value is 10, can you give me what the next value is? If the first value is 10, what will happen to the next term? If this was 10 and the decay rate is 1/2, what will be the value of y when x is 1? So after 10, you half it, it's going to be 5. That's great. So those are simple hacks that will be very, very useful when you're graphing, even though you don't or you're not comfortable with using these points. So as long as you understood what the function is showing you, you'll be able to graph. Okay? All right, let's keep going. Determine whether the table represents a linear or exponential function. Let me explain. Okay, what's your guess for number 1? What are you going to look at? You have to look at whether the x values are increasing by a fixed amount, which in this case, oh, it's going up by 1, right? There you go, plus 1. Now what about the y values? Can you identify a common growth or decay rate? Growth meaning, are you doubling, tripling, quadrupling? Decay means, are you getting the half, 1/3, etc. So what could be like a good, description for the y value? Are they being doubled? They're being halved. It's very good to sell. So if they're being halved or doubled, then it's an exponential function. So if you can find a common multiplier or a common divisor to get the next, okay, number, or sometimes they call it factor, then it's an exponential function. So excuse me. So how do we explain that? So as x increases by 1, okay, y is half. There you go. Did I spell it right? Yeah. Half, you have to change the x. Okay. Now what about in number 2? Ooh, I think x increases by 1, but oh, look at the y value. Can you find a common factor? Can you find a common factor? What's happening? What's happening here? In order to get the next number, are you adding, subtracting, multiplying, or dividing? You're adding 4. Very good. And if it's adding 4, then it's linear. It's not exponential. Okay? Yep. So y increases by 4. So that means it's linear. If it's increasing, yes, yes, the choice is fine. I know it's kind of hard to like write all those stuff in the one note. So if you are adding or subtracting, it's linear, but if it's multiplying or dividing, it's exponential. Okay? I'll leave number 3 to you. Now let's do number 4. What is happening in number 4? If you can't figure out what happened to the fractions or decimals, you can figure out what's happening here, right? So what's happening here? What's the common factor? 6. Okay, so if you add 6 to 0.5, will you also get 2? And then if you add 6 to this, will you get 0.5? If it doesn't work, times 4. Very good. So times 4. And your keyword gives you the answer. When it says times, or if you say times or divide, then you know it's exponential. So as x increases by 1, um, the y is multiplied by 4. Okay, or it's quadruple. All right, so this is exponential. Okay, so that's the basic difference between linear that we did last semester and exponential. If you add or subtract, it's linear. I'm going to leave number 3 to you as a practice, so go ahead and think about it and write in the chat what you think number 3 is. Is it linear or exponential? So is 3 linear or exponential? Linear. Very good, Ryan and Alyssa. Now, why is it linear? Why is it linear? You subtract 3 each time. Very good. Yeah. Now, let me challenge you. How will you write the linear equation for that? How will you write the linear equation for number 3? You're going to write it in the form y equals mx plus b. So you know it's linear. You know 3 is subtracted each time. Uh-huh. So how will you write down the equation? Hello, we subtracted, we forgot listeners already. So what's the b value? What's your initial value? Very good. So negative 3x plus 9. Good job, Alyssa. So the slope is the change in y, which is negative 3, right? Because it's going down, over positive 1. So negative 3 divided by 1 is negative. And your initial value, remember your initial value is always, always, always the value of y when x is 0. So whether it's linear or exponential, that's how you find the initial value. Okay, let's go down a little bit. Oh, okay. Evaluate the function for the given value of x. Evaluate the function for the given value of x. So you're not graphing, you're simply evaluating. So if you're evaluating, you just plug in. Okay? All right. So can you tell me what the answer is to number 5? If you plug in 5 for x. What is y when x is 5? You can do it in your head or you can use your, remember the calculator? Do you remember, did you bookmark the calculator I shared with you last time? It's desmos.com/scientific. Scientific. Okay, there you go. I can't even spell scientific. Alright, you remember this one? Okay, so if you want y is equal to 3 raised to 5. 243, very good to spell. You can also do that in your head. You go 3 times 3 times 3 times 3 times 3. Awesome. Okay, next. Um, next one. What is 1/4 to the third power? 1/4 to the third power. It means you're gonna write 1/4 3 times, or there's a shortcut. You could also go 1/4 to the third is 1 to the third, 4 to the third, whatever that is. So what's the answer? What's the answer? So 4 times 4 times another 4. You can use yours. If you find a handheld calculator at home, you should practice in that one too. Don't feel fun. Okay, what's the answer? What's 3 over 64? I'm gonna take the 64, honey. But for the 3, let's think about it one more time. You're multiplying 1 by itself 3 times. Yeah, so it's going to be 1 over 64. Thank you. Ooh, what did I do? Okay. All right. So that's going to be 1 over 64. All right. So let me erase. Oh my god, it's so much better to not when you're not using a headphone. Okay, I did something wrong. I can't use this ink over here for some reason. Anyway. Okay, so now let's practice. So if you look at these two boxes for the graphing, so the parent function, remember, was 2 to the x, but I mentioned that there could be a value in front, and it doesn't matter what the value is. You use that as your initial. Sorry, what is the first one? Number 5 to 243, if I'm not mistaken. Yeah. Okay. All right. So let's look at this graph over here. I want you to be able to do it even without, you know, even without using your calculator. So you have to understand the idea behind it. So let me explain it again. So your initial value here is the value of your a, and a is the number that does not have, you know, an exponent, right? So what is your initial value for y is equal to 16 times 2 to the x? So what is the value of y when x is 0? Like right when you see a function like that, you should be able to say, oh, this is the initial value. What is it? 16. Very good. Don't even think about it. You know, whatever the value of a is, that's going to be your initial value. Okay, that's your constant. Think of it as your y-intercept. Okay, now the base is telling you whether you're going to make the numbers grow or become smaller. So if it's a whole number, you're going to make the initial value grow by how much? By 2. Okay, so then what will be the next number here? If you use 2 as the factor, 32. Very good. Okay, next, do the same thing. Make it grow by 2. Not add 2, but multiply by 2. What's next? What's next to 32? 64. Very good. Next. Multiply by 2 again. Multiply by 2. 128. Very good. Multiply by 2. Keep going. 256. Keep going. Multiply by 2 again. 512. Very good. And maybe you're thinking, Mr. Arciaga, are you really sure? So let's say, for example, here, that's 60, yeah? Then 2 to the first power. You see that? Because it's 1. So 2 times 1 is 2 times 16 is 32. You know what I'm trying to say? So that's what basically happens. You're just multiplying each one by 2. 2 squared is 4. 16 times 2, and 16 times 4 is 64. Okay? Alright. Next. Here, what's your initial value? You shouldn't be thinking so hard about it. What's 16? Very good. Okay, now tell me what's your multiplier this time? The multiplier here, or factor here, was 2. What's your factor or multiplier this time? 1/2. So you're not going to double. What are you going to do this time? You're going to divide by 2. Okay? So if it's 2, you multiply by 2. If it's 1/2, you divide by 1/2. So what's the next number? 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 1/2. Very good. Or 0.5, right? Okay, so the difference between those two is, okay, I need to show like the one at the bottom. So let me just use them now. I'm going to clear the ink. So the difference between those two things that we did is if the value of b is greater than 1, like when you multiply by a whole number 2, you call that exponential growth because the numbers are growing, they're increasing by that common factor, right? But if the numbers are decreasing by a common divisor, like 1/2 is dividing it by 2, you call that one exponential decay. Alright? So in any exponential function, the initial value is a, the common factor is c, or the base is c. So here are some properties. We know that the graph is curved, right? We see that the y-intercept is the initial value, which is 0a. This is a fancy term right here. It's just a fancy term for, when I showed the graph with the negative side, it just keeps going and going and going, but it doesn't actually pass through the x-axis, right? So you call that an asymptote. Yeah, it gets closer and closer, but never touching it. Okay? All right, and I've mentioned earlier, if the value of b is greater than 1, let's say we use 2 to the x, so the b is greater than 1 over there, that's an exponential growth. But if the b value is a fraction, if the b value is a fraction, then it's an exponential feature. All right, okay, okay. So let's fill up some domain range, etc. So what's a domain if you have 16 times 2 to the x? If you want to see the graph of that, if it helps you better, let me type it over here so you guys can see y is equal to 16 parentheses 2 parentheses x. There you go. Okay, so the domain is what? The domain are the possible values of x. So what's the shortcut? If you put, if you look at the graph, it has a graph on the negative numbers, right? Negative x numbers. And definitely it also has graphs on the positive x side. And in fact, we substituted the value 0, 1, 2, 3, 4 earlier. So the domain here is all real numbers. Is that all the time? Is that true all the time? Yes. In the same way as linear functions also have all real numbers as domain. Now what's the range? What's the range? Let's see. The range is you're gonna find the lowest y value. The lowest y value. What's the lowest y value here? What's the lowest y value here? So it stayed above the x-axis, right? So it doesn't have any negative y value. Okay, so the range will be the positive y. So y is greater than 0. Why did I not put an equal to 0? Because I said earlier it never touches the x-axis. It just keeps getting closer and closer. Now, is it always y greater than 0? No, not necessarily. I'll show you when it becomes a number besides 0. But the domain is same banana, whatever happens. Okay, so when is the increasing? Meaning when is the number, or when is the graph going up from left to right? I think it always goes up from left to right. Okay, so it's, oh, where did the things I wrote? Anyway, so it's increasing from left to right for all real numbers. So that means it's from negative infinity to positive infinity. So remember that, or you can skip all the way. So we don't see a case when the graph is going down. Well, not yet, but we will see that in the future. Okay. So now for this one, okay, let's try this. So the domain again, told you don't even think about it. All real numbers. Let's change. Excuse me. Let's change the 2 here to 0.5. That's 1/2, right? This is 0.5. Okay, so you see this one now? This is definitely going down, right? Okay, so it goes down from left to right. The range is also above the y-axis. So range is y is greater than 0. Okay, and it's decreasing. So here it's increasing. But if the value of the base is a fraction, it decreases from negative infinity to positive infinity. In other words, it decreases for all values. Okay, so those are some of the properties. Algebra 1 is not really heavy on domain range, but Algebra 2 will be. So I don't want Algebra 2 to be your first time to do those. So maybe you're thinking, do we really have to master domain and range? I mean, I'm not gonna like bend your hand to like master them, but it would be good if you like have an idea. Okay? Yeah, I don't teach that in my regular content. Um, I don't go deep. I don't, you know, in terms of domain information, I read the process for you guys. You go to honors process and higher process. Oh, what did I do? Okay, so now let's go to the bottom right there. Here, how? All right, so let's look at this one. So you have to practice graphing. Graph the function and compare the graph to the parent graph, which is y is equal to 2. And then describe the domain range of that. How do you do that? How do you do that? Okay, so let's first make a table of values. Yeah. So the trick here is you have to separate your base. So if the base is 2, is that's your parent function, right? That's your parent function. Okay, so and then you have a negative sign over here. That means your a was -1. Okay, so then when x is 0, what is your initial value? When x is 0, what is your initial value? Remember, it's that part that we shouldn't be thinking so hard about. It's like you just see it right there. So what's the initial value when x is 0? What's your initial number? -1. Very good. Okay, and as we increase x, by how much will our y values go up? As we increase x, by how much are the y values being multiplied or divided? Excuse me. Okay, how do we know? You're going to look at the base, right? What's your base? What's being raised to an exponent? 2. Yeah, just 2. Because we already separated the negative and used it for the initial value, right? Now, guys, don't get me wrong. If like the conceptual way of doing it is confusing you, there's always another way to do it. Like if this is 0, I go -2 to 0. Oh, this is 1. So 1 times negative, that's -1. And then I do it again. 1, -2 to the 1. Oh, wait, 2 to the 1 is 2 times negative is -2. Do you see what I'm doing? So don't think that, oh my god, I didn't understand. So this is just like a simple case of plugging values in. Like 2 squared. Oh, I know that. That's 4. And then I have a negative here, so -4. So you can still get by plugging them in one by one. But I'm just showing you like a faster way of doing it if you understand, the initial value concept and the common factor, then you can just get all these numbers without, writing everything out. Okay, so do whatever works for you. I don't want to be like overwhelmed. I don't get that method. It doesn't mean you can't get anything at all. Okay. All right. So the common factor here is what? And a common factor is just a fancy name. I just don't want to call it, multiplier or divisor all the time because when you go to higher math, and especially when you take AP courses, they're not going to use common words. They're going to use the academic words. So that's your base, right? Okay. So that's your growth factor. So you're going to multiply the previous number by 2. So what will be the next one? 2 times -1 will be -2, right? Same thing that we got if we're doing a table of values the regular way. And then do it again. The growth factor is 2. So what will be your next number? What will be the next number? If the growth factor is 2, you're just multiplying this by, okay, very good, -4. Well, let's do one more. What will be the value when x is equal to 3? You double it again. You multiply it again by 2. Very good. Okay, so let's graph that one. We need mostly y values, so okay. So with x, 0, 1, the y values are -1, -2, -3, -4, 5, 6, 7, 8. All right. So let's graph. The initial value is -1. Okay. Once you get the hang of it, actually you can get rid of the table. You see how I'm doing it? For example, oh, I look at that. It's -1 times 2 to the x. So the initial value is -1. And then if I know the growth factor is 2, I just go straight to the graph and say, okay, the next number is -1, I times it by 2, then I go to -2. So when x is 1, I go to -2. Yeah, that's another shortcut, right? So I'm on -2. Now I have to go to the next x number, but my y should be double of -2, and I go to -4. Okay? And then, oh, the next number when x is 3, I double this, so -4 times 2 is -8. So you can actually graph without making the table, you know? Okay, so then you just go like this. And wherever half of the graph goes, you just extend this. Remember, it doesn't cross your x-axis. Well, not yet. Yeah, we'll see some instances later on if it will cross the x-axis. All right, let's try. Let's try this. Let's try again. Here. So let's make a table. Okay, can you give yourself some time to do this one? I just want to make sure. So you try to separate them, right? 2 times 1/4x. Okay. Now give me at least um okay. All right. So go ahead. Give yourself about 3 minutes to work on that. Do we have a Schoology assignment? You had two exponent or simplifying assignment the other day, right? So if you've done those last meeting, then you don't have anything else this week. Yes? Mhm. So your homework pretty much is to catch up on everything because the grades are closing on Wednesday. So I need to that's why I use this Friday as a cutoff. So I normally sit down either on a Saturday evening or Sunday evening to catch up on grading. So you better make sure that you do whatever you want to be graded for this week by tonight. You're lucky if I see them before Saturday or Sunday. So please do them. Latest will be Saturday 5 p.m. Okay? Did everybody sign in on the attendance sheet? Um, Before you go, I need to double check on this one. So keep graphing, okay? Keep graphing. Keep graphing. Hi, Nick. Happy to see you today, honey. I hope the Zoom works well for you. Okay, there's only like what? Only a handful of names in the attendance sheet. And I don't want to be like getting, messages that you were marked absent just because you forgot to sign in. Please access the sign-in sheet. We should like do that a habit even before we log into Zoom. Like the very first thing we do is sign in to the attendance. Yeah. Okay, can you guys like sign in on the attendance sheet? Just remember, even if you don't Zoom, if your name is on the attendance sheet, you will be marked present. That's LAUSD's definition. So as long as you have a way to like interact with me digitally, text or Schoology message or on the sign-in sheet, or you do a homework on Schoology on the day off, you will be marked present. The choice, none. But you have to do everything that you're missing because I'm grading this weekend. Uh-huh. Yeah. All right. Nico, you haven't signed in, honey. Okay. Dwight was having internet issues earlier. Nico, can you please sign in? Oh, okay, Sophia M is not here. Yeah, guys, I'm like making sure you can access it because if you, oh, Sophia, you here? You sign in. I mean, if I have to do it like for one or two, it's good, it's cool. But if I do it for everybody, it's not cool. I'm not happy with that. Hi, Josh. Joshua. Well, Troy, can you access it? Try to, honey, because what if you can Zoom next time and you don't want to be marked absent? You should be able to like access the attendance sheet, right? What about everything we didn't finish today? Is that homework? I'll go back and check. So no, the one at the bottom is like a next lesson. Okay, so we will go over that Monday. Yep. So the things that you can do for the weekend are your makeup work, and there's a puzzle right here. The puzzle, you can do that already. Yep. Those are just simple graphing, except maybe number 11 through 14. That's the one we didn't cover today. And then enrichment at the bottom. Okay. All right, so let's check your graphs for this one, guys. So what's your initial value for number 11? Initial value is 2. Am I looking at the wrong graph? Yeah, I am. Sorry. Okay, 2. There you go. Next number. Okay, so you're dividing it by 4, right? So 2 divided by 4 is 0.5. Very good. Okay, and then 0.5 divided by 4. Okay, 0.125. And then 0.125 divided by 4. Okay, so 0.03125. Yeah, I don't have a calculator, I'll go 2 over 4 is 1/2, over 4 is 1/8, over 4 is 1/32. All right, you guys. So that whole table can be done like quickly as long as you understand what's the initial value and by how much the numbers are growing or going down, right? All right, you guys. So you can start working on the puzzle, yeah, and we will continue with the graphing next time. The next graphing has transformation, so I don't think we can do all that in one day. So we have to do it another day. All right. So please make sure you guys do your makeup work, okay? And happy weekend, you guys. Take care of yourself, your family. I wanted to remind you to check my progress check exponent. Can you text me, honey? Because once I close the Zoom, like my God, I don't have a record of that. Text me, honey, okay? So I can see it on my phone. And I promise I'll fix that for you. Bye, everybody. Have fun, you guys. You too. Take care. Do we do the stuff after number 8? No, I'm gonna teach you that, but you can do the puzzle, Brian. There's some in the puzzle that we finished already, except the double digits. Yeah, that's 11, 12, 13. The transformations we haven't done that. Thank you. Happy weekend. Bye, you guys.